So this is one way we can measure the rate of reaction. I'm demonstrating this here with about 100 milliliters of vinegar inside. I've already put some baking soda here inside this balloon here. When we're ready, what I'm going to do is I'm going to top up the balloon here, let the baking soda drop into the vinegar. An acid-base reaction is going to occur between the two of them. It's going to release carbon dioxide as a gas. There is only one gas that's being released here, and that gas here is hopefully going to fill up the balloon here. If we had a good way of quantifying how quickly the balloon actually expands, we can just plot here the change in volume of the balloon versus time. So let's just prop this up here. Some baking soda in there. You can probably hear a lot of that bubbling away here. That's just carbon dioxide here. And as you get a sort of qualitative look at carbon dioxide filling this balloon here. We're going to be repeating this demo shortly here using a pressure sensor here, which will help us from necessarily needing to measure how quickly this balloon actually expanded. So. Thanks, guys. Okay, so we're just going to repeat that demo here. This time I'm only using 50 milliliters of vinegar just to make sure the carbon dioxide that gets released doesn't spill over. Instead of trying to measure the volume change of a balloon as it expands, it's really hard to measure quantitatively, I pulled out a GLX probe here. We've already connected an absolute pressure sensor to this here. Essentially what's going to happen is as I drop in the baking soda, that acid-base reaction is going to generate carbon dioxide as a gas. I'm going to try to seal it off as fast as I can. As the carbon dioxide builds up and starts pushing harder on this pressure sensor, we should be able to track how quickly that pressure changes as the time goes onwards. So I've left this GLX menu here on the default menu here. We're starting off on the data files in the upper left. This is where you usually create a new file. I'm just going to toggle to the right to your meter here. Once you punch in your sensor here, it should be able to detect, oh, this is the absolute pressure sensor here. This is actually reading currently about 100 kilopascals. It's the pressure right now. We notice that the pressure isn't changing because no reaction is going on just yet. What I'm going to do instead is I'm just going to press the home button. I'm going to press down 2 to go to the graph setting. And what this is going to do, again, absolute pressure here on the vertical axis, it's going to be sampling the absolute pressure, whatever the pressure is on this rubber stopper as the time goes onwards. So it's going to be able to plot a graph for me in real time. If we can track the change in pressure versus change in time, we have another measure of rate. So I'm just going to set up the system here. I'm going to press the play button just to start the run going, get a baseline for what this is reading here. If you ever need to zoom in here, F1 is defaulting to auto scale. So this will help me zoom in for me here. So currently we're between 100 and 101 kilopascals. And what I'm going to do here is I'm going to try to remove the rubber stopper, put the baking soda in. As that CO2 gets put inside, it should actually go up to the top before coming downwards. So let's just give it a go here. Right. So there's that carbon dioxide. Try to seal off the rubber stopper here so that there's no CO2 that's escaping. Okay. And you see in real time here how that pressure has actually increased as the time has gone onwards. Okay. Qualitatively, as this keeps bubbling away, we know that CO2 is still being released here. We are still slightly above atmospheric pressure, but if you can track this increase in pressure is due to carbon dioxide, we can then do our molar conversions. Okay. Thanks, guys.